weather of the Ape SDK. What I found through that process is, if you can imagine, I have, for a start, this is the simulated planet work. You can see the little apes moving around. There are a few bugs in it, but in general the weather's pretty good. And in general, it's a cube, so we have 6 flat surfaces basically, and they all join up and connect. So this is the weather simulation running over the top of planet, well, whatever it's called, simulated planet. And then also, in addition to this, we have the regular simulation. Here we go. We're missing one window. Let's close this down. So anyway, this is the Bio podcast. And yeah, we're just running the regular simulation. So the idea is that rather than adding thunderstorms immediately, what I will do is make this run this. So get the regular simulation running the planet, which actually proves a little bit more interesting than you might initially imagine. For a start, there's a dynamic where the windows are either double or single scaling. So you need to increase the window size if it moves into a double resolution environment to get down to this level, which is very fine. But nominally, these squares are equivalent to this square, so the aim is to get 6 of these squares here, which is actually quite an interesting simulation exercise because the processing power actually required for that is quite great. So the aim is firstly getting these 6 of these, basically like this, and then the ability to move between high-resolution windows and lower-resolution windows, get things to scale accordingly. And then the simulation will be running a planetary simulation. And what's this got to do with London 1940, you might be asking? Well, I've got to pause London 1940 to work on these aspects of the simulation currently because these metal graphics are just buttery. And getting the graphics working with metal is well worth the effort. So what I have here is actually, the source code is orthogonal. So the simulation, regular simulated ape, uses the same Ape SDK as the planetary simulation, with the view that eventually the planetary simulation will be run through Simulated Ape. And the apes will move around, they'll be larger dots basically, and they'll move around on this with the same kind of movement characteristics, except when they cross over edges, obviously they'll change direction but keep going in a straight line, or forwards basically. It's interesting, a cube, because you have 1, 2, 3, 4, 5, 6, 7, 8 points of discontinuity. So there's interesting topological aspects to simulating a cube, but the vast majority of it is very good, which is why the cube shorthand is what's used in this simulation. So lots of low-level programming, well, not really, lots of movement and mathematics and analysis and just making sure that the weather maintains itself properly, which is particularly interesting. If you look at this window, for example, this window actually loops around. So as the ape moves, it loops around. So this will have to be spatially moving as well. So the ape will probably be located in the center here, and then the rest of this map will just move around as the ape moves around. So it'll be quite an interesting visual effect. And then actually, maybe I'll actually make the cube into a sphere, which would also be a very nice visual effect. So this is what I'm working on currently. Slightly different than the regular London 1940 stuff, but I want to record a video just to give some indication of what's going on.